This is number 3 from Particle Motion AP Review, FRQs. Let's read the problem here. For a time interval from 0 to 12, a particle moves along the x-axis. The velocity of the particle at time t is given by v of t, cosine of pi over 6t. The particle is at position 2, negative 2, at time t equals 0. So x of 0 equals negative 2. For t between 0 and 12, when is the particle moving left? Well, if we want to find when the particle is moving left, we're going to first find our critical points. So we're going to set velocity equal to 0. We're going to create our sign line, and then we'll test our intervals. So here's our velocity function. We set equal to 0. And what we can do here is we can use inverse trig to isolate this pi over 6t. So I'm going to bring the cosine over to the other side and make that will turn into inverse cosine of 0. So pi over 6t is equal to cosine, inverse cosine of 0. Let's figure out what this represents. When is cosine equal to 0? Cosine is equal to 0 at pi over 2 and at 3 pi over 2. So these are two separate expressions, two separate values that we can solve for t at different times. So we'll do this separately. Let's do pi over 6t is equal to pi over 2, and then separately we'll find pi over 6t is equal to 3 pi over 2 and solve for t in both instances. So for the first instance here, if I want to divide by pi over 6, same thing as multiplying by the reciprocal, so I'll multiply it by 6 over pi, and the pi's cancel out. I get 6 divided by 2, which is 3. For the second solving for t here, divide both sides by pi over 6, which is the same thing as multiplying by 6 over pi. Again, the pi's cancel out. We get 18 over 2, which is 9. So our two t values, where velocity is 0, is 3 and 9. We place that on the velocity sign line with 0 and 12 acting as our bounds, as our boundary. And we're going to test each interval here. Here I can test 1, I can test 5, I can test 10. And if I plug in 1 into my velocity function, I'm going to get cosine of pi over 6, which is positive. Here, if I plug in 4, cosine of 4 pi over 6, which is cosine of 2 pi over 3, that's in the second quadrant. Cosine in the second quadrant is negative. And then finally, I can test plugging in 10. So if I plug 10, 10 over 6 is 5 over 3. Cosine of 5 pi over 3 is positive. Cosine in the fourth quadrant is positive. So from here, we know that positive corresponds with moving to the right. Negative corresponds with moving to the left. So particle moves left when velocity is less than 0, and this occurs in the interval from 3 to 9. Okay. For part B, write but do not evaluate an integral expression that gives the total distance traveled by the particle from time t equals 0 to time t equals 6. So total distance, we can use definite integral and absolute value to represent. So we put absolute value just around the v of t, not around the entire integral notation. So just inside the integral notation, but outside the v of t function. Part C, find the acceleration of the particle at time t. So acceleration is the velocity of is the derivative of velocity. So we can apply our rule for derivative here. We know that cosine of u becomes negative sine of u times u prime. We have to involve that chain rule there. So negative sine of u times u prime, the derivative of pi over 6t is pi over 6. And we can clean this up. I can push that coefficient out in front. And now I have my acceleration function. I'm going to evaluate the acceleration at 4. So we're going to take 4 and plug it into the t. So 4 over 6, same thing as 2 pi over 3. Sine of 2 pi over 3 times negative pi over 6 will give us a negative value, and we know acceleration is going to be negative. Okay. The velocity at 4 is cosine of 2 pi over 3, and cosine of 2 pi over 3, plug 4 in for t, we get 4 over 6, which is the same thing as 2 over 3. Cosine of 2 pi over 3, cosine in the second quadrant is negative. So if we want to determine whether the speed of the particle is increasing, decreasing, or neither, we're going to be comparing the signs between velocity and acceleration. So acceleration produces negative, velocity also produces negative, so therefore same signs indicate that the speed of the particle is increasing at time t equals 4, since velocity and acceleration have the same signs. Okay. Find the position of the particle at time t equals 4. So if I want to find the position, we can use the formula final position equals initial plus displacement. X of b equals x of a plus definite integral of v of t. Our initial position is x of 0 is equal to negative 2. So we know that we're starting at time t equals 0, we're ending at time t equals 4. So to bridge that gap, we're going to take the displacement definite integral from 0 to 4 of v of t. All this is without a calculator. So x of 0 we know is negative 2. But once we replace that v of t with cosine, we know we have to go through integral rule to get to where we need to be. So we do have a rule for cosine of u, but we first have to clean this up. So we have to go through u substitution. We'll let the u value be pi over 6t. We find the derivative, cross multiply, solve for dt, and we get 6 over pi du. Replace dt with 6 over pi du, replace the pi over 6t with u, and now we have something that we can go forward with now that all the t's have been removed and have been replaced with in terms of u and du. This is a 6 over pi, it's a coefficient, we can push that out in front, and now we have a nice clean rule that we can apply. Integral of cosine is going to be positive sine, so we bring that back in terms of sine, and we still have to evaluate our bounds, so let's get this back in terms of the original variable in terms of t. Now we're going to plug in. Upper bound is plugged in for t first, minus, then the lower bound. So sine of 4 pi over 6, same thing as sine of 2 pi over 3, which is root 3 over 2 with a coefficient in front. Sine of 0 is just going to be 0, so all this just goes away. So we're only left with 6 root 3 divided by 2 pi, which reduces to be 3 root 3 over pi. But that's only the displacement. We still have to add that resulting value to my initial position. So that plus 2, displacement plus initial position, is going to be the overall value that will take me to the position at t equals 4.